area here, that between those two curves, and the hard part is graphing it. That is not hard.
Throw that in your calculator.
Can't put it in your calculator, it's not y equals. You can, that's a good point. So let's see. I'm trying to think what this looks like. Okay, I remember what it looks like. Well, you know what I do? I do the easy stuff first. Which is easier, the first equation or the second one? Second one. Okay, so what I'm going to do with the second one, and you should have seen this technique in one of your algebra classes, is I'm just going to look for intercepts. Because how many points determine a line? No? 2. 3 non-collinear points will give you a plane. Luckily, we're not doing planes in here. So when x is equal to 0, what's y equal to? Now what I do when I teach in algebra, I cover up the x's because they're not there. Y is what? Negative 16. This is called the intercept method. And when y is 0, what's x? 4. So I can graph that line fairly easily. And I'm not going to probably draw it to scale just because 16 is pretty far down on my axis. In fact, it's so far that's a problem. What's my slope? The slope is going to be 4. So I could start at x equals 4, which is right about here, by my estimation, and I can count over 1 up 4. So it's a pretty steep line. I don't know if I want to make it that steep. Okay? I just graphed the line. I use slope, and I use the x-intercept instead of the y-intercept. The y-intercept is going to be way down off my board, because it's negative 16. It's going to be off your little graph. Okay, Kevin? So how do I do the other one? Well, first off, I mean, you could solve for y, or you could just be a little bit clever. You guys are clever. Often in the wrong way, but you are. Because I know what it's going to look like. Because what if I had x squared minus 4y equals 4? What would that look like? That's a parabola opening up. So what is this going to look like? I switch x and y, what's it going to look like? It's going to look like a parabola on its side. All I need to do is have an idea what it looks like. It doesn't have to be accurate. And you can solve for y if you want. Okay. If x is 0, what's y going to be? 2 or negative 2. Okay, guys? Marcus? And the other intercept is when y is 0. So when y is 0, what's x equal to? Negative 1.
But you can draw it then.
Yeah. I know it's a parabola on its side, so I can draw it. I could solve. You're right. You're going to get a square root. Whoops. And I want that region there. Oh, it's not that bad. Is it? Which way are you going to slice this? Horizontally or vertically? Because if I do it vertically, I've got the curve minus the curve. And then I've got the curve minus the line. So I don't want that. So we will slice it horizontally and give you a chance to work on it. So we'll put it here. And if I put enough of these little slices in, I'll fill up the whole area. It would be tough because it would be, well, that's not right there, but it'd be this one, yes, so it would be y1 minus y2, but y2 is a negative. Because y is equal to the square root of 8x or the negative square root of 8x. Or couldn't you just go from 0 and double it? And then you'd have to stop where.
Then you'd have to stop at that.
You have to stop at that point. Because that's this area, and then this area is different, isn't it? It's the curve minus the line. You just have two integrals. It's not like it's that bad.
But we have to grab
it looks like a codfish.
That one intersection, you just do the...
Sorry, colors. Okay, so,
But we have to graph where they intersect.
no, you're going to solve that algebraically to find where they intersect.
Corners. No, we're on eraser.
You going to watch the video later? Okay, so we'll put, no, we have to do the parametrics.
Yeah, can we learn that? We know how to do this.
Okay, I'll leave this up to you to finish. We can come back.
Yeah, let's go back to that.
And now let's go back and look at this one. Okay. Now, if I have two curves defined parametrically, and honestly, I haven't studied this, I'm going to figure it out as I'm up here. Okay, what's the area trapped between the function and the x-axis? Now, I want to do parametrics, but if I have some curve here and I want to find the area trapped in this region, how do you find that area? Because this is how I remember it. The area is equal to the height, which is the y value, times the thickness, which is change in x, dx. Parametrics are the same exact thing. So when you do the y, you just leave it y. But, so if y is equal to g of t, right here, it's very clever if you think about it. How do you find dx? If x is equal to f of t, dt, then dx is equal to f prime of t, dt. Now, so that's all there is. Now they have to give you the t values here. So we are going to substitute that right into this little formula. So the area is going to be equal to, from t1 to t2, I'll have to figure those out. And it's the y, which is g of t, right, times dx, but that's f prime of t, dt. And the integral is usually tough. Not usually, it's hard to make these easy. Okay, this is a BC test.
How do you find
the times? Because, well, in this case, it's alpha and beta. Sometimes they'll give them to you, otherwise, sometimes we'll have to figure them out. So let's do a problem. That is finished. Let's do a problem that does this. We can come back to it, then they can go. Okay? So if you go to the bottom of your page, there's a problem there, right?
Yep.
Whoops. Estimate the area enclosed by the loop with the parametric curves. We could graph this. Actually doing this isn't too tough to do. We are going to have to get the intersection points off of our graph. So should we actually set this up and then look at the graph? Because the area is equal to, as we know, for Cartesian coordinates, that's y dx. That's all you have to remember. You don't have to remember that fancy formula. So the area is equal to y, which is, and this I think we're going to have to integrate by hand. I mean, not by hand, but with a calculator. Looks nasty. 18t squared plus 25 times, then I need dx. What's dx?
2t plus 1.
Yeah, you'd have to multiply it out. Plus 1 dt.
Yeah, multiply it out.
Or we can just use a graphing calculator. You can multiply it out if you want. Then it's just the power rule.
So where do you integrate it from? Or you just find it?
Oh, this type power is most likely the calculator type. Right, it's most likely the calculator. Yes.
Where do you go? Or is it index?
No. We have to find out where they intersect. So guess what we have to do? We have to look at it.
But you use your calculator like that.
Oh yeah, we're going to use the calculator.
So it's coming out of the calculator.
How do you explain that if you have to use f9 and give the dx?
But it's dt.
Yeah, but
Because you can use x's, they're dummy variables. And I don't have to, but okay, so what do I want to do? Oh, I got to change my mode. I want to be parametric. Now, finding the window is not easy. Okay, y equals. Okay. Hey, who's been playing with my calculator?
Oh gosh. Probably some. Probably.
We're going your pre-algebra kids.
It's whatever.
Isn't that weird?
What?
It's already in there. And we didn't, I mean, I've used parametrics. Hey, the graphing's not easy.
How far? Make sure you watch the video.
Let's see what my window says.
Tell me who wins, guys.
Okay, kind of a standard window. And so let's see what happens with my graph. Or did we do this one before?
I think we did this.
I think we did. Oh, I didn't see anything of interest. So sometimes you have to look at it.
This is so depressing when this happens.
Well, the technology is only as good as the operator. X is always going to be positive. Hey, tell you what, let's do this. Let's go second table.
Wait, you put
Whoa.
it in the way.
What?
The why?
Yeah, that's just the integral. I'm not there. I have to find out where these guys intersect. I have to look at the picture. Mine's already in there for some reason.
Oh.
It's just X and Y. So we go to second table set. Whoops. Then hit the second table set. I can't see that. Where's second? Oh, it's this one. There it is. -3. That looks like a good place to start. Second table. The window is the hard part, but this tells me what I want my windows to be. I obviously don't want to get that little. The X's are only going to go up to 7 maybe, but the Y's, if I want to focus in on here, I don't want them too terribly big. They do go from -63 to 25. We could do 65 to -65. Let's try that. So window, KT, who cares? Well, let's start -3 because that's what we did. And we'll T-step as 0.1, and X min, X was never negative, so let's make it 0. And we went up to 7, I think. And the Y's went from -65, right? See if this works. Yeah, I think we've done this problem before. That's why it's there, it just feels weird. But a lot of weird things always happen to me.
Oh yeah, we've done this.
I looked at the table. I'm still going to make some adjustments because I want the part in the circle. So I don't even want X to get bigger than 2. You guys know how to stop it? It's still thinking. It's still thinking, just press the on key. So window, I want my X just to go up to 2. Oh, make it 3. There it comes. And I would like that a little more spread out.
This one help?
What'd you get?
30. Or 100.
How do you slow it down?
Yeah, that's
Then make your T-step, what's your T-step?
um,
Make it smaller, make it 0.1.
right now.
Oh, then we can make it point, I wouldn't go a 1. It might be too slow. And let's see, my Y values, I don't want to go as,
So slow.
No, you're still.
well, it's above the Y-axis, so I don't care about that. And let's make that 40, because I forgot to check to see how big it was.
Okay, is it 121.5 over 4? That's the same thing. Or,
It might be, I don't know. You want me to bring the slide up? I'd have to do it. Okay, I want the area here. What it's doing is finding, I always have to think about this. The area that's under this part, all right. We're finding this area under here, and then we're going to find the area under here, and we're going to subtract it, basically, is what ends up happening. So it's the same as finding where this intersects both times, because it does do it both times. But that's not hard to do. We have to trace. There is no other way. Now, there might be another way on the Inspire, but I don't know. Notice it's going to, I think it's going to go backwards.
Would anyone in here have Inspire? I do.
Yes? And I have a whole bunch of them. Gotta find my cursor. Is it coming? There it is. Okay. Well, we can still find that. And you could integrate from here to here and then there to there and subtract them. Or you could just integrate from the first time they intersect to the second time. And if you want me to talk about that more on Monday, I can. Okay, so let's just take that picture, put it there. Keep tracing. It's going backwards. And the second time it intersects is right there. Okay, so that's what you do. Now I got to figure out which one's first. I believe, because it's going backwards, I have to start at 3.35 and integrate to negative 1.35. But you know what? It's easy to figure out. Why? Is that 3.5 or 0.35? Why is it easy to figure out? If I'm doing it wrong, what's going to happen to my answer? It'll be negative. So what I would do is put this into y1, because I'm going to mess up my parentheses, and put that into y2, and then multiply. Just a trick, that's all. Well, it's going backwards. So I'm going to integrate from negative 1.3, I may have it backwards, 35 to this place called A. Right? And because it's going backwards, that to make that a positive number, I got to put in negative because it's going the wrong way. And then it's plus from A to 0.35. Actually, I think it's minus. Because you want to take, actually you want to take this area minus that area. So you want the area under this curve minus the area under that curve. It's just going the wrong direction. So it doesn't matter. All we have to do is integrate from there to there.
Just look at the 2 points.
Right. And the way we're going to find out is to do it.
The 1.25 you just did there was.
Well, we're just going to do it.
They were one apart.
Where's my graph? There it is. Okay, so I'm going to quit. Oh, and I say I don't have that in Y1. Let's see. Do you want me to put, I don't want to use the, I'm going to change my mode. Why am I going to change my mode? Because I don't want to go and find all those parametric ones. Easier. We know where they are in the function mode. Okay, so now we're going to press y equals, and they're dummy variables, so I don't really care. That's 3x to the fourth.
So we just type all that in.
Well, it's easier than multiplying that out. But you could, if you, because you have a cast, you could just put that in your calculator and multiply it. That stage, I think I just put it all in and let the calculator do it all. Okay. And then the other one I'm going to put in, what is that one? 2t plus 1. This is just a technique. You can do it however you'd like it. You could put it all into y1.
I think at the top one, I forgot.
I forgot to get rid of what?
Go to the part.
I don't think it was that long, was it?
No, go to the part. Right. No, you have like a squared symbol on top of it.
18x squared plus 25. I don't see anything else there.
5 squared.
Oh, how'd that happen?
So it was there from earlier. You also have a plus back here.
And you just didn't it. Really? Okay,
Yeah, that was us. There's one. Yeah.
weird. Okay. So, second, quit math, and we're going to do 9. And I'm going to go from, I think I'm right, 0.35. I always have to think about this. But you know what? If it's not right, I'll just put a minus sign in front. Because that's all it's going to be wrong. It'll be the sign. And then we want, that was y1 times y2. So bars.
Negative 1.35, right?
Well, yeah.
You have 1 minus 35.
Yeah, I did something wrong there.
You just typed it.
Yeah. Times, oh, that's easy. Bars. That's easy to do. Y2. I'll fix that in a second. Oops. I'm going to cheat. Because I can't do this. You guys really should get the new operating system. Oh, it doesn't let me do that. That's too bad. That doesn't let me do that. Okay, so I got to go back and fix this. there's supposed to be a decimal there, right? Negative 1.8. Don't pound on the wall.
Which he's sitting.
I know.
She said, "Don't pound on the wall." That was that.
Okay.
Why would you pound on our wall? They're the ones who are loud.
Oh, I didn't get my X in the right place.
I was looking right at you.
This is being touchy today. This could be operator error. Syntax error.
No. Did you use X? Oh, yeah, you did.
Oh, it doesn't like that. No, it's that exponent that was
Yeah,
there.
that's the wall pounder.
Yeah, that's the wall pounder.
And then all I have to do is go up here and grab it again. You can do second enter and that'll do the same thing. That's right. That's negative, so I have it in the wrong order. But that's easy to fix. If you're on the exam, that's the reason why I don't like the setup but do not integrate. We can.
Did you know what cough smells like?
Yep. It does.
What does that smell?
Okay, vocab 70 times. I need to be here for everything else.
Okay. Did we set this up? We didn't set it up. I don't know what it is. I have to look it up. It's going to be x1 minus x2 dy. And which variable do we want here? X or y? I want the y's because this tells me what variable. So if I solve for x in terms of y here, x squared equals 4 plus 4y. So x is equal to the square root of that. No, I'm in the wrong one. Sorry. Solve for x here. That was the inverse. Sorry. So I get 4x equals y squared minus 4. So x is, sorry, it's a mess. X equals y squared over 4 minus 4 over 4. Now that's the curve, so that's the x2. x1 is y equals, is the line. So solving this for x in terms of y is, let's see, I'll add y to both sides. I want x in terms of y, never mind, yeah. 16 plus y, and so x equals 16 over 4 plus y over 4. Okay, so x1 was the line, that's this one. So it's 4 plus y over 4. Minus the other one, which is y squared over 4 minus 4 over 4, but that's just 1. Because to do it vertically, it wasn't going to be pretty. To do it vertically, I'd have to do the curve minus the curve here, and over here, I'd be doing the curve that's up there minus the line. I'd have to have two integrals, and then I'd have to solve for y in terms of x here, so I have to figure out the two equations. It just seems like a lot more work. But now, you need to find where they intersect. And it looks like that's going to be not very nice, but it's not bad at all. Because we're clever. Are you guys clever? I need to solve this nonlinear system, and the only way we know how to do it is substitution unless something nice happens. Does anybody see what happens that's really nice? If you add these equations, what happens to the x's? They cancel out. So you get y squared minus y equals 20. Okay, you guys, how do you solve for any equation? Second, set it equal to 0. So y squared minus y minus 20 equals 0. Factor it. Minus 5 plus 4, right? So you're going to integrate from negative 4 to 5. That's algebra. Is that what you had?
Okay, I'm sorry to interrupt. I want to buy some things, so can you come down? I went to eat them.
Nice, yeah.
Okay, what do you got? What's
Yeah, that's it. Can you integrate that? Do you want me to bring up another slide with the answer on it? I can.
Yeah, all I want is the number.
I agree with that.
Okay, I'm going to stop the recording.
Wait, what is she
I
about?
want to make sure that I integrate it correctly.
But did you get that? They're doing butter braids.
I